and because the number in front of the x squared, the quadratic term, is 1, I can just use my simple method of factoring. And what is that simple method of factoring? I can simply figure out the product, which is always my last term, and that's negative 18. My sum, in this case, is the middle term, the coefficient of the middle term, so that's 7. And now I have to think about two numbers that multiply to negative 18 and add to 7, and that will be 9 and negative 2. That pair will multiply to negative 18 and add to positive 7. Because this is a simple case, I can just go into my brackets, my factored expression. Each one will lead with x, and then the other two terms will be plus 9 and minus 2. And that's it, we're done. This is a simple case, my awesome shortcut that I can use, and I can go ahead and write down my answer. So x plus 9 and x minus 2, and I'm done. This is it. I have fully factored it because it's a simple trinomial. The next question says, and I know that I actually changed it during the test. The question should read, find f of negative 3 if f of x is equal to, so find f of negative 3 if f of x is equal to 3 minus x, and I did that on purpose. So if you want to look for f of negative 3, remember the rule is wherever you see x, you're going to replace it with negative 3. So I see x right there, I'm going to replace that with negative 3. The negative that already exists is not part of that negative 3, so I have to keep writing it. And then I put in my negative 3 here, and this ends up being 3 minus negative 3, which is the same as 3 plus 3, and that's equal to 6. So my correct answer is 6, not 0, as most people figure it out. This question here really talks about maximizing and setting up an equation for maximizing revenue. So we are going to have lots of maximize and minimize questions. This is just one type. In this question, I'm asked to maximize revenue. And revenue is really how much I charge per item times how many items, the number of items that I'm selling. The initial amount that Lucas is doing is he's selling these tournament tickets for $50, and he's going to sell 80 of them. So that's the initial condition, 80 tickets for $50. Now he decides to increase the ticket price by $2. So this number here, he's going to increase it by $2. So how do I write that? Well, that's plus 2. Now, he doesn't know how many times he should be increasing it because he wants to maximize his profit. Every time he increases it, same thing, something happens with the number of tickets that he sells, and it should come as no surprise that the number of tickets that he sells decreases, and it decreases by 3 tickets. So now he doesn't know how many times he should increase the price because every time he increases the price, he gets more money per person, but he has less people. So we've got to find this perfect combination. And I mean, you could do, go one by one and figure it out. And you'll go he's going to sell $50, charge $50 and sell 80 tickets. And then he's going to charge $52. And if that happens, he would be selling 77 tickets. If he charged $54, he would be selling 3 less, so 74, and so on and so on. And then you want to find which one is the largest of these, which one is the largest revenue. However, we don't want to do that because it's not very efficient. I mean, if the values were larger and there was cents involved and such, it would just take, it would be too time consuming. So we're going to try and find out an algebra way to do this. And a perfect way to do it is to recognize that, hey, I want to figure out how many times it's going to increase the price. So we're going to let X represent the number of price increases. So how many times he's going to increase the price. So now this would then mean that every time he increases the price, so he adds $2, we're going to add an X to it. So it's going to be 2X, 2 times X, because X is really the number of times he's going to increase it. And that's what we're trying to figure out. Now we also have to adjust our number of people that are coming, because every time he adds $2, the number of tickets sold goes down by 3. And how many times is this going to happen? We don't know. It's going to happen X times, X being the number of price increases, so the number of times he increases the price. And that's it. This is the entire equation that we want to come up with. It turns out to be a quadratic. And then what we would have to do if this problem asked, we would have to expand it, and then we would have to complete the square to determine the maximum. This question doesn't ask that, but if it did, we would then have to go about and find the maximum. Luckily, we don't have to do that here. We simply just have to figure out what expression is a good expression for revenue, and that's this one right here, the one that includes adding $2 to the ticket price and subtracting 3 people from how many people will attend. The next question here, all right, I'm asking you to find the area underneath a rectangle, and everybody knows area of a rectangle is length times width. That's easy enough. So length times width, and then I'm giving you length, I'm giving you width, and then I just need you to multiply the two of them together. So that's it. So area equals length times width. And what's my length here? Length is equal to square root of 25 times 4, or plus 4. And then my width, I'll put that in a bracket because that's my entire length. And my height or width, whatever the other dimension is, square root of 75 plus 10. Now, I would normally FOIL this, but I don't have to FOIL it yet because I can actually simplify it first. You could FOIL it from the start, but I would urge you to simplify first because you can simplify and make your life a lot easier. Square root of 25, that's just 5 plus 4. So my first bracket is really just 5 plus 4. Square root of 75 can be split into square root of 25 times 3. And I'm choosing 25 times 3 because, again, 25 is a perfect square. 5 plus 4 in the first bracket. Again, I could expand using foiling here. However, why don't I just simplify this? I can easily simplify it and get 5 plus 4 is 9. And then bracket, I've got square root of 25 and square root of 3 plus 10. This is fantastic. I've got 9. And then square root of 25 is just 5 root 3 plus 10. That's great. And now the only other thing, I mean, you could technically leave it like this. However, another thing that we could do is we could expand, meaning we could distribute the 9 into the bracket. And 9 times 5 is really 45. Square root 3 does not get multiplied in with 9 because 9 is not underneath the square root. Therefore, we cannot incorporate it in with 3. It only gets multiplied by 5. Root 3 stays part of the expression, but nothing gets multiplied into root 3. Plus 9 times 10 is 90. And this is it. So this is the ideal solution. Either one of these would have worked in this case. So that's really what you should be writing. I'm going to use the second one, 45 SQRT3, square root 3 plus 90. State the domain for this function here, f of x. So when we have a square root function, we know, we talked about this in class, that anything under a square root can be 0 or larger. So I'm going to write that right away. Square root, whatever is underneath a square root, must be greater than or equal to 0. All right? Stuff outside of the square root doesn't count. That can be anything. But stuff inside of the square root must be 0. So this time I've got 4x minus 3. And that whole thing must be greater than or equal to 0. This is how this equation or this question will start. So now we're going to solve for x. And the first thing that we're going to do is we're going to get rid of the square root by raising it to an exponent 2. And that's awesome. It really helps us get rid of the square root. So I have 4x minus 3 is greater than or equal to 0 because 0 squared is still 0. And continuing our solution here, I'm going to move the negative 3 to the other side. So I'll end up with 4x is greater than or equal to positive 3. And then I'm going to divide both sides by 4 and end up with x must be greater than or equal to 3 over 4. So that's my restriction. So my domain is x can be any number such that x must be greater than or equal to 3/4. So where is that? There it goes in the bottom. I already circled it. So that's my correct answer. All the other ones are wrong for one reason or another. 4 over 3 here, less than 3 over 4 here, greater than or equal to 0 here, and not equal to. All of these are wrong. X must be greater than or equal to 3 over 4, 3/4. All right, we're nearly there. It says write the range of this function. Now, this will be impossible because if you're just looking at it because you're probably thinking, what does this look like? I have no clue what this equation is, but you have to get used to it. This equation is very, very typical, and it's an equation of a circle with the center at the origin, so 0, 0. So the equation is x squared plus y squared equals 49. Equation of a circle is x squared plus y squared is equal to r squared, r being the radius. So the first question is, well, what is the radius of this circle? And I'm hoping that you can recognize that 49 is not the radius. You have to take a square root and write it out as 7 squared. So that's really what 49 is. So my radius is actually 7. And if I'm to sketch that on an XY grid, I'm going to change my color just for 1 sec, I can literally just mark off 7 all the way around my grid, minus 7, and that is my radius, and then I'm going to draw my circle all the way around. And what's my range? Well, range is all the numbers between -7 and +7. How do I write that? How do I write that? First of all, range is my y values. So I'm going to say y can be any number, y-e-r, y is an element of real numbers, such that, and then my lowest y is -7, that's down here, and then y can be anything, all the way up to +7, that's it. So -7 is the lowest, 7 is the highest, y is sandwiched in between, and then I got to put an inequality there. So y must be greater than -7 or equal to, and y has to be less than or equal to +7. So this is the correct ordering, and that is that choice, the fourth choice right here. 21, it says answer. I believe that this one I said not to do because there is a typo in here. I will show you what you should have done if you corrected the typo. The question should have read 9x squared plus 12x plus 4. So that's what the question should have said, and this is why I said don't do it. It should have said 9x squared plus 12x plus 4. If I wanted to do it, I would, to factor it, because that's what I'm asked to do, I would try and do product sum. Now, product sum would mean that I would have to figure out what two numbers multiply to 36 and add to 12. However, there's a shortcut here, and the shortcut is that I can recognize that, hey, the first term and the last term are both perfect squares. So this is my case of a perfect square trinomial, meaning I can write it as something times itself, or something to the exponent 2. And what is that something? Easy if you recognize it. It's square root of the first term, which in this case would be 3x, and square root of the last term, which in this case is 2. So it's really 3x plus 2 times itself. And is that true? Can I do this? Well, if you just think about it and try and FOIL this or expand it, you have to ask yourself, will you come up with the original? Because that's really what you should get. That's how you can always check your factoring. And if I do that, I can just do 3x times 3x, that's 9x squared, that checks out. The middle term would be 3x times 2, which is 6x, and then I have another 2 times 3x, which is another 6x. When I add that up, I'll get 12x. That's awesome. And then the last will be 2 times 2, and that's really equal to 4, and that's what I have here. So that's fantastic. That checks out, and I am so happy I was able to use the shortcut instead of doing product sum, because that would have taken me a lot longer. 3x plus 2 can be written as 3x plus 2 all squared. So that's what I would write in as my answer here, bracket 3x plus 2 all squared. Question number 22, the time that the pendulum swings. All right, the swinging pendulum question. All right, let's see what this question brings us. So it gives us an equation, and the equation is t is equal to 2 pi and then square root of L over 32. And L is the length of the pendulum, and T is the period, so how long it takes to swing back and forth. So if the pendulum is here, it swings back and forth, right? So they're telling us to find T, which is find the period, when the length is equal to 8. So all we have to do is replace L with 8 and figure it out. So this is what you should have come up with, and I know that most people in the class did do this, but then some people had issues simplifying it. And the only thing you have to do here is, first of all, recognize that 8 over 32, both of these guys can be divided by 8. So I can simplify my fraction. 8 divided by 8 is 1, 32 divided by 8 is 4, and there is my Awesome fraction. Now I can actually distribute that square root. The square root of 1 over 4 is the same thing as square root of 1 over square root of 4. How do I know that? Because when we talked about square root of n times m, I said that you can really write square root of n times square root of m. If I was to use numbers, if I had square root of 25 times 3, I could really write it as, so if I had square root of 25 times 3, I can really write it as square root of 25 times square root of 3. Well, guess what? Same rule applies for division. So if I had one thing divided by another, which is what a fraction is, I can in fact split it up into two separate roots. So that's what I'm doing here. And if I split this up into two separate roots, I'm going to get a really simple answer, and I'm going to end up with t is equal to 2 pi times 1 over 2. Now we're simply multiplying here. So if I just rearrange these values, because when you multiply, you can have your multiplication values in any order, you'll still get the same answer. I can write this as 2 times 1 over 2 times pi. And I hope that you can recognize that 2 times 1/2 is really just 1. So this is just 1 pi. So the answer is 1 pi, or pi. And that's it. Last question. I have to match these up. And really, how do you figure out matching these up? I'm really asking you to look at the actual factoring methods and look at the equations. Difference of squares should be pretty straightforward. You have two terms, and both of them are perfect squares. Sum of squares, which is underneath here, x squared plus 25, that actually doesn't exist. That you cannot factor, so that's why it's associated with does not factor. Complex trinomial decomposition is used when the leading number is other than 1. So here the leading number is 2, which makes it a complicated trinomial, which means it's a complex trinomial, and we have to use the process of decomposition to factor it. Perfect square trinomial, well, the leading number and the last number is a perfect square, and we can take a square root of them. Simple trinomial is a case when the leading number in front of the x squared is 1, and that's the case here. And that's really it. So that's what we really were looking to get. And if I press continue,